Right, so as a starter, there's 4 questions on here. I'm actually going to change this last one. Let's just do these 3 questions. I just want you to solve these, please, and I want 3 answers. You've got 3 minutes. Go. Okay, so what do we get? Inverse sine of 0.5, we've got 30 degrees. Yeah? Here we get 3x equals 11.54, and then what did you do? Divide by 3. Brilliant. 3.85, okay? Degrees. Okay, how about the last one?
Sine inverse of 0 equals 2x plus 1.
Yep. What's
So
sine of 0?
0.
Okay.
So then I move the 1 to the other side.
2x equals minus 1, x equals negative a half. Brilliant. Okay. What if I now told you I want you to solve this within the interval 0 is less than or equal to x is less than or equal to 720 degrees. Would your answers change? Would they not? Would they stay the same? Would you add more? Would you take away more? Tell me what's going to happen now. Off you go. Okay, so well done for that discussion. Let's take this one as a prime example. This one's the easiest one to take. If I was to draw the sine graph, first of all, between 0 and 720, it's going to look like this. We're going to have 1, that's going to stop where? 360, and then I'm going to go again, aren't I? And that's going to stop where? Okay, so I've now drawn my graph in this interval. Now, remember, this is my x-axis and this is my y-axis. If y equals sine of x, I'm now saying, what would x be when y is 0.5? So 0.5 equals sine of x. Where is 0.5 roughly? I know this is 1. So 0.5 is roughly here, right? So I have 0.5. If I was to draw a line at 0.5 to see where they intersect, how many solutions should I expect between 0 and 720? 4, because it crosses the line 4 times. 1, 2, 3, 4. Now, for this type of question, it's quite easy to use symmetry. And if we know that this is, in fact, the first one our calculator gives us is the one that's closest to 0, by the way. Sometimes we get a negative, but that's because it will be closer to 0, right? So this is 30 degrees. How can I use symmetry to then find out what this would be? Yeah, I know this is 180. It is going to be the same distance away, so 180 minus, so our next value is 150. Brilliant. Okay, how am I now going to find this value here? Yeah, 360 plus 30, which is 390. And then this value here would be, this is 540 minus, which is 510. Okay, so this is fine for this type of graph. We can use symmetry. Some of you won't even have to draw this out. Okay? So this is technically what we're going to be doing. However, the questions we're going to be looking at are going to be a little bit more difficult. For example, let's try, I'm going to make up a question. Sine of 2x, 2 sine 2x minus 2 equals 1. Okay? How, and I want this between the interval of minus 360 is less than or equal to 0, is less than or equal to 360. So I want you to use the graph to do this, please. Okay? I'm going to give you a few minutes. Off you go. Sorry, guys. This is supposed to be an X. I was going to draw. There we go. Thank you. So I think some of you spotted straight away that that means that sine of 2x minus 2 equals a half. Okay? So that means that 2x minus 2 equals 30 degrees, yeah? Because we did inverse sine. So what did everyone do? Did we add 2 to both sides? Yeah, so we got 2x equals 32, and then what did we do? Divided by 2, x equals 16, and then you drew the graph, didn't you? Yeah, you did this, and then you were like, right, it's here, we go down, it's here, we go down, yeah, and here, yeah? Okay, this is completely and utterly wrong. Okay, this is incorrect. Okay? And this is probably one of the biggest mistakes that people make. Before, guys, we do the add 2 and the divide by 2, we actually need to find out the rest of them from here. And then we do this to each one. Okay? The only other way we could do this is if we already know that this is a transformation. Is it inside or outside the bracket? Inside. Who does it affect? X. Okay. So until you fully understand what these transformations are and are willing to draw the graph of this, okay, willing to draw this graph without, and then you can look at symmetry, that would work. Okay? Or if you just got to this step, you know a half is 30, you know the next one is 150. Okay? So what we're going to look at is how we're going to use the CAS diagram to help us. This CAS diagram will help us every time. Okay? So that's what we're introducing today, is how to do the CAS diagram. Okay, so for this step, this is perfect, okay? And then for this step, we would also change the interval to help us. This is going to be one of the harder questions that we look at today, so we're going to start with the basics. Are we ready for the basics? Brilliant. Okay, so just a quick recap with the CAS diagram. What is this one labelled as? All. A, because all of them are positive here, yeah? Okay, how about this one? Sine. Brilliant. This one? Tan. And then the last one? Cos. Okay, this is now going to help us. Well, what we're actually doing is, as we saw in yesterday's lesson, we've mapped the graph onto this diagram. Yeah? However, when we do the negative versions, it obviously changes. So the best way to remember this is as follows. So let's say we chose sine of theta to equal a half, cos of theta to equal a half, and tan of theta to equal a half, okay? And then down here, I'm just going to have the negative versions, just so you can see what's happening each time I have a negative or positive with tan or cos. So, first of all, for sine, the easiest way to remember is once you've done your first degree, you reflect always in this vertical line, okay? With cos, we reflect in this line, and then with tan, just carry on the diagonal, whatever might happen, okay? So, this is how it's going to look. We know that sine of a half, we know we get 30 degrees. This is 30 degrees. We reflect here, 30 degrees, okay? We know cos of a half is 60 degrees. So with cos, I'm going to reflect here, 60, and then here, 60. And then tan of a half is, in fact, 26 degrees. So I'm going to go here, 26 degrees, and then I'm going to carry that diagonal on 26 degrees, okay? When we're doing the negative, I'm going to get negative 26 degrees. That's here. And then with tan again, I carry on that diagonal, okay? With cos of negative 0.5, I'm going to have 120 degrees. 120 degrees is here, This is my angle. Where do I reflect cos? In which line? The horizontal. So now this is going to be here. Okay, and when I do in negative 0.54 sine, I do get negative 30, which is fine, and then I'm going to reflect that in that line. This is how I'm drawing these each time. So even though we have the cast diagram, it's easier to remember that sine we reflect in the vertical line, cos we reflect in the horizontal line, and with tan we follow the diagonal through. Okay, nice little handy tip for you. And we're going to look more into that now. Okay, so here we go. Are we ready to start solving these? Now, as you can see, they've actually given us 3 answers, okay? Now, for these questions that we're doing today, you're going to see I'm going to tell you how many answers we should be looking for. We're now going to look at how to use this cast diagram. So, first of all, I get solve tan theta equals -3 in this interval between 0 and 540. We know with the cast diagram, we start at 0. This is 90. 270, 180, I got a bit ahead of myself there, didn't I? 180, 270, 360, what comes after 360? 450, 540. So whatever I do, I'm going to have to start here, I'm going to have to go round once, and then go round and I'm going to stop here. Okay, because the interval is between 0 and 540. Okay? That is what the question's given us. So step 1, I'm just making sure that we're all happy with this. Okay, step 2. This means theta equals inverse tan of -3. So when I put that into my calculator, -3, I get theta equals -71.57 degrees. So far this is what I've done. I'm now going to show you how to use this cast diagram. Okay, so first of all, what do we notice about the value of tan? What's it giving me?
Negative.
A negative. Okay, it's giving me a negative. Now, some people don't teach starting with negatives. I do, because I don't want anyone to think that any is harder than the other. It's all really easy once we understand how to use this diagram. So here we go. First of all, if this is 0 to 90, where would -90 be? Yeah, so this would be -90, right? So we go this way round all the positives. If we went this way round, would be negatives. So this would be -90 here. So step 1 is always drawing this angle. It doesn't matter if it's a sine, cos, or tan. Doesn't matter. Where would -71.5 go? Would I draw that here, for example? No, of course not. Would I draw it here? No. If I was to draw an angle here, if I was to draw this angle, what would you say this angle is? 71. Okay. Is it positive? Yeah, okay. If I was to draw this angle here, what would you say this angle was? About 150? Yeah? Okay. Remember, because we measure from 0, if we go this way, it's positive, okay? So, minus 71.57 is roughly about here. Would you say this is minus 71?
Yeah, somewhere there.
0.6. I'm going to do because it wants 1 decimal place. Roughly. It doesn't have to be exact. Okay? So if I go this way, this is about minus 71.7. Brilliant. So we start here. Now with tan, if we were to use the cast diagram normally, if we had 71 degrees here, we would reflect it in this line here because it's tan. Okay, so tan is always a diagonal. So with this line here, I'm going to continue this line all the way up to here, and I know that this angle is exactly the same. It's 71.6 degrees. Okay, so once I've drawn this diagram, I now start the question. Are we ready? So we've got to get from 0 to 540. So if I start at 0, and I start going round in the circle, I cross it here. This is technically where our first intersection is. How am I going to figure out what this whole angle is?
90 plus 180.
180 minus 71.6. Brilliant. So 180 minus 71.6 is going to give me 108.4. So that's my next angle. Okay, then I go round again. When is the next time I hit this? Here. This is 360 minus 71.6. Brilliant. Which is going to give me 288.4 degrees. When I get to here, it means I get to the 360 line. Do I stop there? No, because my interval told us not to. Technically now, when I cross this line, I'm at 450. When I intersect again here, this is going to be 540 minus 71.6. So this then gives me 468.4. I then get to here and I stop. Why am I stopping here? Yeah, because the interval is between 0 and 540. Now you can see I have 4 solutions. However, it only wants the one between 0 and 540. So that means my answer is 108.4 degrees, 288.4 degrees, and 468.4 degrees. And that is how I figured out all my solutions using this cast diagram. Okay, next one. We're going to solve sine theta between 0 and 360. So I know I'm going to start at 0, go all the way round, and finish at 360. So I'm only going to go round once, right? So step 1. Theta equal then sine to the minus 1 of minus 0.06, which equals, so shift sine minus 0.06. I'm going to get minus 3.4 degrees. 2 decimal places, sorry. 3.44 degrees. Now, where would I draw minus 3.44 degrees? Probably literally be here, wouldn't it? Okay? Now, when we're dealing with positives in the cast diagram, A and S, we would, for sine, we would go here and we'd reflect in the vertical line. I still need to reflect in the same line. Okay? So for sine, I'm going to reflect it here. Okay? So I know this is 3.44 degrees. So now I'm going to start. So once we've drawn this, we start again at 0. We start at 0, we head to 90. Have we intersected yet? No. We get to 180. Have we intersected yet? We get to this line. Have we intersected? Yes. What is this value? 180 plus 3.44. So 183.44. Brilliant. I keep going. I get here to 70. No. Keep going. I intersect here. How would I find this one? 360 minus the answer, 3.44, which is 356.56 degrees. I then get to here and I stop. Why am I stopping? Because it's after 360. Okay, I have 2 answers which are between 0 and 360. It's 183.44 and 356.56. So just to double check, guys, this angle, if I was to actually draw this angle right now, okay, if I started here and my angle finished here, that is technically what's happened here. I'm measuring this angle. So this angle is 180 plus that 3.44. It's literally just measuring angles. This is how it's helping us. Okay, so here we have sine. Okay, try and give this one a go. Okay, so we have 45 degrees, which we know is here. Okay, this is sine, so I'm going to reflect in the vertical line. I reflect my angle. Here we have it. So now I start my journey. Okay, I start my journey. I start at 0. Where's the first one I cross?
45.
45. Brilliant. I carry on. When do I intersect again? Here. How would I work out this angle? 180 minus 45, which is 135 degrees. I'm then going to carry on. Here, where am I now? 360. Do I carry on?
Yeah. So
I get to here.
450 minus 45.
This is 360 plus 45. Okay, which is 405 degrees. Then we'd carry on going round. Do I intersect again? Here. What is this? It's 540 minus 45, which is 395. No. 495 degrees. I carry on going round until I get to 720 and I stop because that is the end of my interval. So I have 4 solutions here. Okay, so here we know that theta equals inverse sine of 0.95. I'm going to put that into my calculator. Shift sine 0.95 and I'm going to get 71.8 degrees. It wants one decimal place. 71.8 degrees. If 0 is here, roughly about there. So 71.8 degrees. So this positive sign I'm going to be reflecting in this vertical line, which is here. So this is 71.8 degrees. So essentially what I'm finding is, first of all, I'm going to start at 0. My interval finishes at 360. I go across and I cross my first one at 71.8, which we already have. I keep going, I get to 90. I keep going, I get to this one. Now, what is this angle? This angle here is essentially 180 minus 71.8. Imagine a straight line. You've been given this. So we're going to have 180 minus 71.8. It's going to give us 108.2 degrees. And then I carry on round here, 270. I'm going to stop here. I'm not going to go any further because my interval is at 360. So my 2 solutions are 71.8 degrees and 108.2 degrees. Okay, so cos equals this, and our interval is between minus 180 and 360. So if I draw my CAS diagram, I know this is 0, 180, 360, and then remember I've got to go backwards as well. If I go backwards, it's going to be minus 180. Okay, backwards is this way. Okay, that's what's going to give me my negatives, my positives. I'm going to go around this way. Okay. However, step 1 is the same for any question, regardless of whether it's cos, sine, or tan. First of all, we're going to find the inverse of the number to find the angle. I'm going to get 71.9. Now, it doesn't matter if this is sine, cos, or tan. Theta equals 71.9. 71.9 degrees is roughly this. So I always mark this on, 71.9 degrees, okay? Now I look at which trig it is, and this is cos, so I reflect it in this line here. So this is going to also be 71.9 degrees. Okay, and now I start my question. So when I'm going from minus 180 to 360, I can do this 2 ways. I can start from 0 to 360, and then I can go back and then do 0 to minus 180. It's completely and entirely up to you what you do. So let's have a look at this. I'm going to start at 0 and go to 360 first. So if I start at 0, I intersect once at 71.9, which I already have. I carry on going all the way around and I intersect here. Now this angle from 0 all the way here is 360 minus 71.9. So this is going to give me 288.1. Okay? And then if I was to carry on round, I'm going to stop there because I get to 360. So that is me going clockwise from 0 to 360. So I've stopped there. However, really I should have started at minus 180. But it goes backwards. So I'm going to go backwards. So if I'm at 0 and I go back, I cross here. 0 minus 71.9 is, you guessed it, minus 71.9 degrees. And then I carry on going. And then I'm going to stop at minus 180. So as you can see here, I've gone round and I've gone from 0 to 360 and then 0 to minus 180. And I have 3 answers. Okay, so now we're moving on from the basic style questions. We're going to have a look at the questions where the interval is changed here. Now, the best advice I can give you is we're going to solve this as normal. However, we are going to change our interval. So what have they done to theta here? They've multiplied theta by 2 and minus 120. I need to do the same thing. So if I multiply theta by 2, I need to multiply my interval by 2. So I get 360 to minus 360. And then they've minus 20. So if I minus my theta by 20, I'm going to get 340 minus 380. This now tells me what to do. So sine of 2 theta minus 20 equals 0.98. That means 2 theta minus 20 equals shift sine 0.98. Okay, we're going to have 78.5 degrees. Now, just to make our life easier for this one, we're just going to do to one significant figure. So I'm just going to do 79 degrees, okay? One significant figure. So before we add 20 to both sides and divide by 2, we're actually first going to use our new interval and then apply the transformation. Okay, so this is essentially what's happening here. This is the transformation of the sine graph. We know that it's because it's inside the bracket. We've what have we done here? Doubled all the x values, or technically we've halved them all, and then added 20. Okay, so what we need to do is, okay, so now we're going to draw our cast diagram. We know our angle is 79 degrees. This is sine, so we take this to the opposite side here. Okay, and remember, we are now going from minus 380 to 340. First of all, I'm going to start at 0 and I'm going to do to 360. Okay, I'm going to do the positives first. So I know I'm going to get 78 is our first one, and I'm going to get 180 minus 78, go round, and this is it for the positives. Okay, so I'm going to get 101. Now, no, it's not 101. No, it's 101. Okay, so now I'm going to do the negatives. So if this is 0, this is minus 90, minus 180, minus 270, minus 360, and technically, guys, I should have finished here at 340, okay? And technically, we're going to go finish at minus, this would actually be minus 380, okay? So let's see, let's start at 0. I get to minus 90, nothing, minus 80, nothing. I get to here. It's our first one. So this is minus 180 minus 79. So minus 180 minus 79 is going to give me minus 259 degrees. Okay? Then I'll keep going round and I have another interval here. Okay? This one is technically minus 360 plus 79 degrees. So minus 360 plus 79 degrees is minus 281 degrees, and then I'll keep going round and stop when I get to minus 480. So I've got 4 values of my theta, which I now need to actually find what theta is. Currently I have 2 theta minus 20 equals this. Let's find out what theta equals. Okay, so now to find out what theta is, I need to add 20 to everything. So I'm going to get 99, 121, minus 239, minus 261. And then to find theta, I need to divide everything by 2. Okay, so we're going to get 49.5, 60.5, minus 119.5, and minus 130.5. And these are the four answers. So during the other videos, you will see me using the CAS method. Now, as I said, this isn't the only method to use. I didn't actually use this for my A-levels. I used symmetry. However, when I was introduced to this and I started teaching it, I actually really, really loved it. So, yeah, I hope this helps, and good luck with everything. Well done. Yeah, also going to say thank you to Dr. Frost. He has these on his key skills. I would highly suggest you sign up and you do the key skills on this just to get some practice, because it will mark all the work. Thank you.